Hey guys, welcome back to my channel Vedic Math Vantage, where we learn maths the easy way. So if you've been following me, you will notice that we have covered topics of addition, subtraction and multiplication. And from this video, we'll be starting with going over the division techniques from Vedic maths. And this video, we will be starting with the divisibility rules. So let's jump right in. Let's begin. Today, we'll be going over all the divisibility rules from 2 to 12. And of course, you might have learned most, if not all of these divisibility rules in your regular school, but I'll just be revising over them and I'll be teaching you one divisibility rule that I'm pretty sure you wouldn't have heard of before, which is for 7. But let's begin one by one. So starting with 2. So it's simple. You need to have an even number for it to be divisible. So any number 4 or 1, 9, 2 or 2, 6, 8, all are divisible by 2. Any even number. So every alternate number is divisible by 2. No big deal in this. Next, for 3, the digit sum or the sum of all digits should be a multiple of 3 or equal to 3 itself. So let me just write digit sum ds 3. Okay, so take a number. Okay, 1, 9, 5. Let's go with that. And so you have 1 plus 9, 10 plus 5. Okay, you have 15. 15 is a multiple of 3. Okay, but the reason, 3, 6 or 9. The reason I said that it should be equal to this is because even when you get a 2-digit number, you know it's already divisible. But when you add it further, it just becomes clearer that it's divisible. See, when you get a 2-digit number or a 3-digit number or whatever as your digit sum, you continue adding. You keep adding till you get a simple number which is within the first 10 multiples of 3, or which you know as a multiple of 3. And that confirms that the number will be a multiple of 3. Okay, so that means you can have numbers like simple as 27, which is in the first 10 multiples. You can have, like we said, 195. Or you can have 2, 6, 3, 4 even. All of these work. Okay. Next, for 4. Last 2 digits should be divisible by 4. Okay. So when you have any number 3, 5, 6, 8, 2, 9, 6, check only the last 2 digits to know whether it's divisible by 4 or not. Because for 4, you need to have 2 2's in the prime factorization of the number. In the sense that when you prime factorize a number, you will get 2 twice, because 4 is 2 times 2. So this makes sure that you have that. Okay, it doesn't matter what the rest of the digits are. Here we have 96 and we know 96 is divisible by 4, or you could divide and check if it's a little challenging to do mentally, but you'll know that the number is divisible by 4. Okay. Next, for divisibility check of 5. For this, the last digit should be either 5 or 0. One of the two. Doesn't matter what the digits are. If the last digit has 5 or 0, then the whole thing is divisible by 5. I'm sure you've already learned all of these rules in your school. But anyway, next we have 6. So basically, you know the divisibility rule for 3, you know for 2. 6 is 2 into 3. So it comes that it should be divisible by 2 and 3. Okay? So it should be an even number for divisible by 2, and the sum of its digits should be equal to or be a multiple of 3. Then it will be divisible by 6. As simple as that. Now 7. This is what I promised you today. So let me just explain. It's a very simple rule that you could also do in your head like most of the others. Okay? Take a number 3, 4, 3. Now what you do, take the last digit, double it. So in this case it's 3, double would be 6, and subtract 6 from the remaining digit. So 34, not 3, don't include 3 in this. 34 minus 6, you have 28. And you know that 28 is a multiple of 7. So that means 343 is divisible by 7. Okay? You can even sometimes get your final difference as 0. And that also makes it divisible. But if you get anything 1, 2, 3, 9, 17, anything that's not a multiple of 7, then it's not divisible. Let me show you another example of a slightly bigger number. I'm taking random numbers here, so I'm not sure if it will be divisible or not. But let's check. So we have 2, 9, 3, 4, 6. 5 digits enough for now. So take 6, last digit. Okay, double it, you have 12. So 2934 minus 12. That gives you 2. Of course, you don't know yet if it's divisible. So you repeat the process. Take this. So 2's double is 4. 292 minus 4. We have 288. Okay, some of you may already know whether it's divisible or not, okay, just by observing at this point. But let me just continue the process. 8 double is 16. So 28 minus 16, just by observation. You don't even have to do the subtraction, but sure, if you would like to. 12 is the final answer. And of course 12 is not divisible by 7, so that means 29,346 is also not divisible by 7. That's how it works. I hope you understood this simple technique. You double the last digit. in this case L would be last digit. Okay, and then that you subtract from okay, from the final or the remaining digits. So basically the rest of the digits. Okay, next we have 8. So now we have 8 as our next number. So to divide by 8, last 3 digits, I think you might have understood the pattern by now, but last 3 digits should be divisible by 8. Okay, so basically take any number and check the last 3 digits if it's divisible by 8, and that will decide whether your number is divisible by 8 or not. Okay, next for 9. Okay, it should have 2 3s in its prime factorization. So here the technique is same, digit sum, but digit sum should be equal to 9 or a multiple of 9, because otherwise the given number wouldn't be a multiple of 9. So for 3 you can get 3, 6 or 9 as the digit sum. Okay, then it will be divisible by 3. But for 9, the digit sum should be 9 or a multiple of 9. Okay, and for 10 I'm pretty sure you all know it. Okay, you just need last digit equals 0, then it will be divisible by 10. Okay, that's very simple. For 11, I'm thinking you all must have learned this in school. If you don't remember, let me just refresh. Okay, basically take sum of the odd placed digits and subtract it from the sum of the even placed digits. Quick example, let's take a number. Okay, we can go for 1 3 3 1. Okay, so the odd placed digits, meaning from the left here 1 2 3 4, so that's how they are placed, right? 1 2 3 4. This is the placement of the digits. Now you add the odd placed digits. Okay, so in this case odd numbers are 1 and 3, so you add this one with this 3 and subtract it from 2 and 4. So this 3 and this 1. So 1 plus 3 minus 1 plus 3 gives a 0, and 0 or any multiple of 11 if you get as the difference, then it is divisible by 11. So let's, if we assume that even placed digits are E and odd placed digits are odd, so sum of even placed digits minus sum of odd placed digits should be divisible by 11. Okay, and last, it's very simple. 12 is 3 into 4, so of course I think you can predict the divisibility rule. 3, it should be divisible by 3, and for 4 it should be divisible by 4. Then it will be divisible by 12. Okay, so for 3, the sum of all digits should be a multiple of 3. For 4, the last 2 digits must be divisible by 4, and you have a number that is divisible by 12. And that's all. These are the basic divisibility rules, which is mostly what you will be needing when you're doing LCM or HCF or those kind of problems. These divisibility rules will be really helpful. Most of the rules that you saw in this video were actually those that you might already know from your school mathematics. But I included some rules like the divisibility rule for 7 from Vedic maths. I hope you enjoyed it. See you again next week.